Well, hello everyone. Today I'm going to solve the problem that used to select the student to join the honor program at the KMUTT University of Technology, Thonburi or KMUTT. And at this in this university we have like an honor program, which is a program that we they designed it for the student who want to challenge themselves in the specific field like the mathematics, physics, and chemistry. And this is this is the access of the problem that they use to select the student to join this program. That it consists of three questions, three main questions, and for each and it covers just the mechanic part, which is the first three chapters, first two or three chapters in the holiday books or in that curriculum. um so we are going to talk about the questions and how to solve the question. Sorry that I really apologize that the problem and the solution I wrote is in Thai. So, but I will present it and try to explain it in English. So we will just capture the numbers that show the variable that shown in the statement and just follow my calculation, my math. So the universal language that we are going to use is mathematics. So I think is easy to understand if you understand math. So we are going to talk about the first question. The first question is just stated that we have an incline and two mass, and then there is um the setup as shown in the figure like this, and then they assign the value for each variable, like m1 is equal to 2 kilogram, m2 equal to 6 kilogram, and theta is 30 degree, and assume that g, or the gravitational acceleration, is 10 meter per second square. And we assume the ideal case, like no friction on the incline, no friction between incline and surface, and uh yeah, just find the surface and the tension in the string. So to solve this problem, we just need to re redraw the setup, the diagram again, and yeah, as you know that the pulley is frictionless and the surface is frictionless. And one more thing that I didn't mention is that the incline is fixed on the horizontal plane. Then what we are going to do, as you know that this system is quite the ideal system, so not much to be considered. So we are going to consider the free body diagram of, oh sorry, the free body diagram of each mass. So let's talk about the mass one first. As you can see that the mass one, we assume now we have to assume, we assume that the direction of motion is downward. That means is the weight of the mass one is greater than the string, so the direction of motion will go down like this. Then the from the Newton's second law, we find that the summation F equal to ma, and yeah, since the weight of the m1 is greater than t, so we can write the first equation like this, and we assume that the string is weightless, is really light, so don't need to consider about the weight of the string. Then we are going to consider the force acts on the mass 2. So we have the T pull in this direction, the slanting direction. And since the weight is go down vertically, and we know that the angle between the normal line is the line that perpendicular to the inclined surface, and also the surface of the bottom surface of the mass 1. Then is yeah, it's make the angle of theta to the the vector of weight, and then we just separate the component, and we get that the component of m2g cos theta is already cancelled with the normal force. So the normal force that the incline act on the mass 1, the mass 2. So the remaining force is the m2g sine theta. Then we set the equation because uh, we still believe that the direction of motion is go in this direction along the string, along the string, downward the string. So the t is greater than m2g sine theta, and we make the Newton second law. And one thing you have to keep in your mind that when we talk about the free body diagram, free body just means that we have to separate the body. There is no interaction, no anything with other component of the system. We just consider that mass and the force that act on that mass. Don't need to consider the other stuff. So it will make you really confused about the force, and you may add up some force that you already have in the equation, but you add it more because you're confused about the diagram that you draw. So one thing to keep in your mind is that you have to separate the mass and carefully consider about each term and set the equation. Then we sum the equation 1 and equation 2, so the t is cancelled and we get this relationship. Then we can solve for the acceleration, the system acceleration, as shown in equation 3. Then we can substitute the a in the equation 3 in either equation 2 or equation 1. So the tension will be equal to this term, and then we just substitute the value of each variable. But I'm so sorry that in the problem, as I mentioned, the g is equal to 10, but I used the 9.8. So but I already made some calculation, and I see that the answer is really close. It's like if we substitute g equal to 10, we'll get like 22.5 Newton. But with the significant figure, which is actually is just 1, but we'll use like 2, so it's 22 Newton. So this is the end of the first problem. So the thing that we get from this, the concept that they try to measure from the student, is that the use of the free body diagram, the Newton's second law, the how to separate the component of the vector of the force and stuff. And I think that is a very conceptual one. Yeah, so we'll move to the next question. Yeah, if you don't understand or you cannot catch up with my speech, so you can just leave some comment on or just message me directly so I can answer you. So this one is really easy, the simplest question in this test, but yeah, the statement is quite long. So it's like we have a rabbit that can jump forward and backward in just one dimension, and every time the rabbit jump forward, then it will jump backward and repeat this step continuously. So to calculate, we set the condition like t at t equal to 0 second. The rabbit is at x naught equal to 0 meter, and every 1 second the position of the rabbit will be the x1 equal to 1 in unit of meters, and x2 equal to 0.5, x3 equal to 1.5 So you can see the pattern is that if yeah, from x0 we started, yeah, from x0 it started with 0, then it's plus 1 and minus zero point 0.5 plus 1 and minus zero point 0.5 plus 1 and minus zero point 0.5 continuously. Then the first question asks us to calculate the distance and the average speed of the lap bit during the interval of from 0 second to 10 seconds. So it's oh sorry, what should I do? Okay, then yeah, as you can see that is plus 1 minus zero point 0.5 plus 1 minus zero point 0.5 continuously, repeatedly. So the distance from 0 to 10 is just 5 multiplied with 1 because it's like uh yeah, from x naught to x10 is took like 10 curve. I will call this as a curve. It took 10 curves, but half of them is plus 1 meter forward, and half of them is zero point 0.5 backward. But they ask us to calculate the distance, not the displacement. So we will take the absolute value. We will not consider the direction, just the magnitude. So we'll get like 7.5 because 5 curves of 1 meter plus 5 curves of zero point 0.5 meters. So 7.5, 7.5 meters. And the average speed, very easy. Just the distance over time. 10 minus 0 is 10. So we got 0.75 meter per second. And the displacement from 0 to 2 seconds is 0.5. Yeah, 0 to 2.5. And the average is just divided by 2 because delta t 2 minus 0. So we obtain 0.25 meter per second, the same as 8 to 10. 2.5 minus 2 is 0.5 over 2.25. And as you can see that the middle point of 0 to 2 is 1, and middle point from 8 to 10 is 9. And the problem asks to find the average acceleration from 1 to 9. So we can just use the average speed that that cover 9 as a middle minus the average speed that covered 1 the first second as a middle. And as you can see from the previous answers, the previous solutions, you can see that it is equal. So it's 0 over delta time. And no matter what delta time is, so the result will be 0. And I don't think that the delta time is 0. So is it 0? The answer is 0. You can just imagine like this. I'll draw that along the path. Oh, I'll do along the pathway of, oh, it's the highlighter. So yes, yeah, assume that we have like the coordinate, the graph, and I'll do that along the pathway. Along this pathway, it may look like this, but if the problem asks us to find the average, this is the v and t. To find the average acceleration, we have to find from the starting point, the final point back to the starting point, and yeah, it is 0, right? No matter how the curve look like during the initial point to final point, but averagely is from the final and the first point. so it's just the horizontal line, so the average acceleration is 0. So we are going to move to the hardest question of this test. Um, this question will determine the understanding of the law of the conservation, the conservation law of energy, and some kind of two-dimension motion, the parabola and the projectile, and yeah, mostly is what makes this problem really difficult is the mathematics that we have to be careful during solving the mathematic problem, which is the 3D. Uh, 3D is not three dimension, but the problem number 3D. Uh, so yeah, there is a plenty of variables in this problem. So we have to be careful. Then we are going to read the problem. We have the tiny sphere, and this tiny sphere will compress the spring with the displacement equal to d from the equilibrium, and then yeah, the spring constant is equal to k, and when we release the spring, it will move from v0, yeah, that the v not equal to 0, from the point 0 to point 1, and there is no friction during this this part, and then it will enter to the part with the friction region, and after that it will go down with the speed of v2, and that v2 will be the initial speed um, to initiate the projectile motion. And we have the sphere have a mass of m, and the gravitational acceleration is g, and the height from the ground to the mass one is h. So the first question asks us to find the v1, the second one to find the v2, and the third one to find the r, which is the distance from the equilibrium point of the spring to the landing point of the object. So let's solve it step by step. So first of all, the first one from the point 0 to point 1. Yes, it's just like the transformation of the energy that from the potential form to the kinetic form. Like at first time we have the object at the equilibrium, and then we compress the string, so we yeah we add work to the system, and that work become the kinetic and the potential energy in the store in the spring. And when we release the spring, then uh, the potential energy in this in that store in the spring will become the kinetic energy for the sphere to move. So we can just set the conservation of law of energy, the E before equal to B up equal to E after, and the E before we have the kinetic energy too, but we not is 0, and yeah, this one we have the EP spring too, but is at the equilibrium, so D is 0, so it's becomes 0. Then we can solve for v1 like this. Okay, then the second phase is the phase that has a friction. So the energy in the right side, yeah, it because it started with the energy from the previous phase. Like the previous phase, we have the transformation from the potential energy to the kinetic energy, but this time the kinetic energy will decrease as the the force try to resist the motion, and that resistance cause the work that the system lost the energy by the friction. So we have to subtract the energy, the kinetic energy at the first time, the initial kinetic energy, and then we will obtain the final kinetic energy, and then we just express the term since this is the work from the friction, and the friction is mu. And oh yeah, in the problem they stated just the mu is the coefficient of friction, but doesn't mention that which kind of friction, the kinetic one or the static one, but we will assume that is the kinetic one because during this phase the object is moving. So it will be mu n multiplied with s because work defined as the force multiplied with the displacement in the same direction with the vector of force. So it will be mu mgx, and then we just substitute v1 equal to d multiply with the square root of k over m, and then we just expand the full form and take a square root, so we obtain the v2. Then yeah, continue from that page. So the next question asks us to find the L, which is the distance from the equilibrium of the spring to the landing point of the sphere. So L can be defined as the x. X is the region with the friction, because after we release the spring, the object the spring stop at its equilibrium, and then the object enter the region of the friction, and that region will be equal to x, and it will be included as an L as a part of L. So L can be defined as x plus capital X. So yeah, as you know that the distance in the horizontal line or the capital X is the u, the horizontal u, the horizontal component of u multiplied with t. But how can we find t? So we are going to consider the free fall. This is just a projectile motion, so we can solve for the time by just set the equation of motion. We said that the upward direction is positive and downward is negative, so the minus h equal to, since there is no vertical component for the initial velocity, so this will be 0, and minus because downward is negative, so minus a half of gt squared. So then we can solve for t, and then we multiply t with the vx, v initial x. So we obtain the L as the relationship, as this relationship. And the last problem and very difficult one, as to finding the x that will provide us the maximum value of L. So as you know that this kind of question, especially in mathematics, to find the extremum, we just find its derivative and just let it equal to 0 and just solve for the x, or solve for the things that will be used as an input in order to obtain the output, the output with maximum value. So in this case, we are going to find the derivative of L, and the L can be expressed in this term, so we can just distribute the d by dx to each term. So this one is dx by dx, and very easy, equal to 1. And this one is d by dx, and we just pull out this term from these two terms. So inside inside the square root we get this. And yeah, the instructor, the examiner is really kind. They provide us the differential formula, so we just make it in the same form. And we, yeah, this one is constant, so we can pull out in front of d by dx. And yeah, we just assign this big term as an alpha, and then we obtain the things that really similar to the formula provided. Then we just follow the derivative step, no, not the derivative step, just the formula, and obtain the result like this. And then we just, yeah, you just open the box of alpha, so we get this big term back. And then what you have to do, send this negative sign and operate, yeah, plus minus with the one, so we can just uh, add this term on both sides, so we get 1 equal to this term, right? And then we have to reduce to make it simpler. Then what we are going to do is to multiply with this term on both sides, and we obtain this and this. Yeah, multiply with this is equal to 1, and this occur. And then what we did is just to square on both sides and just move this to this side. What we need is x, then we multiply with d square over k and divide by mu mg on both sides. We obtain this relationship, and then we just subtract mu h on both sides, and then we get x equal to d square k over 2 mu mg minus mu h, which will give us the maximum value of L. So thank you very much for listening, and I really hope that you get something from my speech and in my lecture, because it's like I'm so tired today. I just took the knowledge, the credit time for exam, and yeah, isn't is five the 2 o'clock in the morning, so um I'm shattered. So thank you very much again for listening. And if you have a question, I think that there is a lot of problem, like um my sentence formation, my vocabulary shows and stuff, a lot of things, a lot of grammatical error, and a lot of things. But I don't want you to take that into account that much, because I want you to focus on the physics and the academic knowledge that I try to teach you through this video. And if you want me to solve some problem, to teach you something, or to do this kind of thing again, just message me or leave the comment. And yeah, if you find any loopholes in this video, you can tell me, so I can just edit and improve it in the future, as a future plan. So see you.